This is something you're familiar with and you've probably done many times before. We're just reviewing the procedures. So solving equations with variables on each side. And let's just proceed to example 1. You can read over this introductory part here. And they start with 2 plus 5k equals 3k minus 6. And it goes through the reciprocal operations. You're going to get all the variables on one side, all the numbers on the other side, using additive inverses and then multiplicative inverses. So subtract 3k from both sides to get 2 plus 2k on one side equals negative 6. Subtract 2 from both sides. By the way, there's nothing to stop you from doing this all in one step, subtracting 2 from both sides and subtracting 3k from both sides. I have these all set out at different steps so you can just see what's going on, and if you're a little rusty, maybe you want to go one step at a time. The main thing is you want to end up at the right place. Now notice I like doing inline subtraction as opposed to, if you look in the example, they do the subtraction stacked, like if you were doing arithmetic. I'm just showing you a different way of doing it. My way isn't better. I wouldn't say it's worse. It's just different. I would like you to be exposed to both ways of doing it. Do it in the book if that's how you like it. It's probably how you've been taught. But the way I'm doing it is a little bit more algebraic. But anyway, it's certainly not better or worse. Now, the most important thing, no matter how you get there, you get to an answer. Okay, we end up with k equals negative 4. Is to check. Once you're dealing with an equation, you can check your answer. And checking your answer is like cheating. Because, well, it's not cheating, but I mean what it is it will always tell you for sure whether your answer is right or not. If your answer is wrong, you go back and find out where you were wrong. So checking is really a good thing to do, and I'm going to absolutely, positively insist that you check. And if I don't see checking in your work, your homework or whatever, you're not going to get credit for it. So for this point in your life, you will be checking. So anyway, there's 1a. And now here's the next one. 3w plus 2 equals 7w. You do the reciprocal operations, and you end up with w equals 1/2. Plug it in to check it. Here's the check. Let me write down this. Check. Okay. And I get to 7/2 just because it's just because it's a fraction doesn't mean we're not going to check. Okay, so here's 1b. Let me move down the pages here. Go to the next page. Okay, so here's 1b. 5a plus 2 equals 6 minus 7a. I subtract 5a from both sides. I'm sorry, I add 7a to both sides, pardon me. Add 7a to both sides. Subtract 2 from both sides. Divide both sides by 12. I get a equals 1/3. And then I check. And when you check, you always take your answer, in this case a equals 1/3, and plug it back into the original equation, not any of the intermediary equations, which are the result of work that you have done. Plug it back into the original, and I end up with 11/3 equals 11/3. Definitely do this. 1c. Now I do this problem a little bit differently than they do it in the book. Oh no, actually they don't have an answer for this in the books. All right, so here's what I did. I am going to multiply every term, and there's 4 terms. x over 2, first term. 1 is the second term, plus 1. 1/4 x is the third term here on the right side. And minus 6, that's the fourth term. I'm going to multiply every term by the common denominator, which is 4. 4 over 1 times x over 2 plus 4 over 1 times 1 plus 4 over 1 times x over 4 minus 4 over 1 times 6. Okay, so that is going to eliminate all the fractions. So I get 2x plus 4 equals x minus 24. Subtract x from both sides. Subtract 4 from both sides. And I get x equals negative 28. And then I check. I keep forgetting to write check in here. Check. Okay, and I go through the various machinations, and I ended up with negative 13 equals negative 13. 1D. Okay, here's another technique. Okay, so the first two problems were very straightforward. These did reciprocal operations until you ended up with an answer, and you check the answer. Okay, in C, I multiplied every term by the common denominator in order to eliminate fractions. And that turned it into a problem like the first two, 1A and 1B. In 1D, everything has a decimal has one decimal place. 1.3c equals 3.3c plus 2.8. Now, they want you to just subtract the 1.3 from both sides, and that leaves 2. 2c equals 2.8. Okay, well, that's all right. But the technique I would like you to keep in mind and to use is to multiply every term by the power of 10 that eliminates the decimal place. So every term has one decimal place, right? 1, 2, 3, one decimal place. So if you multiply everything by 10, 1.3c times 10 equals 3.3c times 10 plus 2.8 times 10, you end up with 13c equals 33c plus 28. All the decimal places are gone. And now subtract 13c from both sides, and you get 0 equals 20c plus 28. Subtract 28 from both sides. 20c equals negative 28. Divide both sides by 20, and c equals negative 7/5. Now, you're probably thinking, well, this is really terrible, but it's not really. Just plug it in. In this case, I don't even bother getting rid of the decimal places. Negative 7/5. 7 times 13, it's 91, so it's going to be negative 9.1 over 5. 33 times 7, not hard to figure out. 23, that's going to be negative 23.1 over 5. Plus 2.8. Now I want to turn 2.8 into fifths. So I multiply the top and the bottom by 5. I get negative 9.1 over 5 equals negative 23.1 over 5 plus 14.0 over 5. Negative 19.1 over 5 equals negative 19.1 over 5. Now, you could do this on your calculator to check it. The thing I worry about with all of you, is whether or not you're going to get into rounding and how you're going to do stuff. I'd like to see you doing stuff like this as far as possible without your calculator, just to build up your adeptness with your basic operations of multiply, add, subtract, multiply, and divide. Okay. So example 2, grouping symbols. All right. Now, right here with example 2, grouping symbols, they do this differently than the way I do it. And again, the way they do it in the book is fine, but I want you to see the way I'm doing it, because they do they distribute the 6 with the 5m minus 3, no problem. You get 30m minus 18. On the right side, they distribute the third. So 24 times 1/3 is 8, and 12 times 1/3 is 4. So you get 8m plus 4 on the right side. Now you have a very easy equation to solve, just like the ones we've been doing. However, suppose it was 25m plus 13 or 11 or whatever, then multiplying by 1/3 is going to create a lot of fractions for you. A technique that I would like you to consider using is, after you've distributed the 6, so you got 30m minus 18, multiply both sides by the multiplicative inverse of 1/3 to turn it into 1. So multiply the right side by 3, the right parenthesis by 3, and the left parenthesis by 3. This eliminates any potential fractions. And it's much more likely that that coefficient, that fractional coefficient, will result in more fractions if you distribute it. It's just a matter of coincidence, or actually they intentionally set it up to make both these terms divisible by 3. So I would recommend that you consider using the multiplicative inverse, multiply both sides by the multiplicative inverse of whatever this fractional coefficient is, to get rid of the fraction. So now we have 90m minus 54 equals 24m plus 12. Subtract 24m from both sides. Add 54 to both sides. We get 66m equals 66. M equals 1. And it's quite easy to check. Now, 2a, I think it's just some practice. Let's see here. Yeah, here we go. Just to do the distribution, 8s minus 10 equals 18 minus 6x. Do the checking. 2b, more distribution. Now, here's the thing. Okay. Watch this. Whenever the coefficient for the parentheses, I shouldn't use the term for coefficient, that really refers to the number that multiplies a variable. Let's use, and I'm using it to use, the factor, okay? Whenever the factor multiplying the parentheses is negative, you've got to be very careful, okay? Because that negative factor is going to change the sign of both terms inside the parenthesis. So we end up with a -6 and a -2n. And this effect is, I think, is most commonly misunderstood or confused or whatever when the factor is simply -1 expressed as a negative sign. So -3 plus n will often end up as -3 plus n, where the second term, the student forgets, or whoever, the person doing the math, forgets to negate the second term when the factor is simply -1 expressed as a negative sign. Okay? And that situation is called the secret agent by a really, really great math teacher named Escalante. He's really, really legendary. I made a great movie about him called Stand and Deliver. I strongly recommend it. Okay. So watch out for the secret agent when you have a negative sign as a factor for a couple of terms inside parentheses. And sometimes these terms will have negative signs themselves, and then you really got to watch out. Okay. So you distribute the -2, -6, minus 2n, and then do the reciprocal operations. Add 2n to both sides, add 7 to both sides. 9n equals 1, n equals 1/9. Plug it in. Not hard to check. Not hard to check at all. Okay, just a little bit of fraction work, nothing terrible. The more ease you have with fractions in algebra and with unusual factors, either decimal or fractional factors, the better you're going to do at the subject and at higher levels of math as well. Okay, example 3, special solutions. Some equations have no solutions, and then some are true for all real numbers. These equations are called entities. We don't have a special name for equations that have no solutions. We just say there are no solutions. Okay, so how do these things, I know you've seen it before. We're just kind of jogging the old memory here. So we got a 5x plus 5 equals 3 times 5x, parenthesis, 5x minus 4 minus 10x. Eliminate the parenthesis. We get 5x plus 5 equals 15x minus 12 minus 10x. Combine like terms. 5x plus 5 equals 5x minus 12. Now subtract 5x from both sides, and you get 5, which is not equal to negative 12. No value of x, no matter what you come up with, can make this equation true. So it is no solution. B. So when you end up with two numbers, all the x's have been canceled out, and you got one number on one side of the equation and a different number on the other side, you have no solution. Okay, because no number of x can make 5 equal negative 12. All right. Or, can make a equal b if they're two different numbers. Okay, b. 3 times 2b minus 1, in parenthesis, minus 7 equals 6b minus 10. Eliminate parenthesis, combine like terms, reciprocal operations. The 6 b's cancel out, and you're left with negative 10 equals negative 10. Okay, any real number you plug in for b will make this equation true. Any real number in the real number set of real numbers will make this true. This is called an identity. So this has an infinite number of solutions. This first example had no solution. This one has an infinite number of solutions, and it's called an identity. We got 3a and 3b, which are examples of each. Okay, you go through all the rigmarole in 3a, eliminate parentheses, combine like terms, reciprocal operations, get all the variables on looks like you're getting them all. Try to get them all on one side, but they all cancel out. You're left with negative 5 equals negative 5. Any value of x will make this equation true. You can put in anything you want for x. Negative a billion, Googleplex, pi, e. No matter what you put in, you're going to end up with negative 5 equals negative 5. Okay, infinite number of solutions, and it is an identity. 3b. Okay, eliminate parentheses, combine like terms. You subtract 6y from both sides, and you get negative 30 equals 20. No possible value of y will make this equation true. There is no solution. No special name, just no solutions. Okay, and then we have test example 4. 10x equals 6 times x plus 3. Okay, now with the test example, I think they want you to actually work out the examples. They got the steps for solving equations here. This is all stuff you know how to do. You can look this over. Simplify expressions on each side, distributive property. So eliminate parentheses, combine like terms, get all the variables on one side and the numbers on the other, and then isolate x. End up with 1x. Okay, let's see where this example is. Okay. Now, they want you to take each answer and plug it in and then see if it works. That's fine. Okay, you want to do it that way? That's fine. I do it algebraically here. This is an algebra class. It's not a plugging and chugging class, but it's a good test-taking technique. So look at what they're doing here. On the other hand, if the answer happens to be D, you're going to be plugging and chugging 4 different times. Whereas if you use algebra, you're solving it once. So, it's kind of up to you how you want to do this. Okay? But anyway, I set it up so that 2 times 6 plus x, actually, hold on. Okay, anyway, so I set it up, find the value of x so the figures have the same area. So you got 10, it's length times width for, you don't know if these are rectangles or squares or whatever. So 10x equals 6 times x plus 3. and distribute and get all the numbers on the left and numbers on the right and the variables on the left, etc., etc. And I end up with x equals 4.5, and I check it. So you got to weigh it against, this didn't take that long to do the algebra and get the right answer versus plugging in the answer. And I'll leave that, you to decide how you want to handle that. But know both techniques, and you make up your mind. You're taking the test. It's up to you, but you should know both techniques. Guided practice number 4 or number here. So let's see what this is. Okay, find the value of x so the figures have the same perimeter. So 2 times x plus 6. Okay, so there's 2 sides that measure 6, and there's 2 sides that measure x, so it's 2 times 6 plus x equals 2 times x plus 2x plus 2. So there's one side that's 2x plus 2, there's another side that's 2x plus 2, and there's 2 sides that are x. I just could have written them as 2 times 6 plus 2 times x. So I distribute. Anyway, so 2 times 6 plus x, in other words, half the perimeter, equals 2 times half of the perimeter of the other figure, x plus 2x plus 2. Distribute 2x plus 12 equals, and I combine like terms inside the parenthesis, 2 times 3x plus 2. 2x plus 12 equals 6x plus 4. Subtract 2x from both sides. Subtract 4 from both sides. I get 4x equals 8. X equals 2. Plug it in, and it checks. Okay. That's it for the introduction. Now we're ready to start the homework. That'll be a different tape.